I better start faster because as soon as I get it on and I'm with you, I'm more focused on what I want to do. So let's do it because Ehsan sent us some extra material adding to the description of the problem. Do you have it or no? Let me check. Yes, you got it. Okay, what is the problem? This is this category, comparing the comparables. Whole set ranking via structured presentation of organic items. First of all, we are talking about organics because we know there is another team in this on these platforms that are focused on sponsored products in subcategories. Customer problem: eBay does not effectively showcase the breadth of inventory for broad query with heterogeneous product types. So their types, which is the categories, is heterogeneous, and Nike winner takes all. And all of the problem comes because human beings are affecting the feedback system. Takes all items from, and they have unpredictable behavior. Or okay, maybe actually economists believe that we can predict it. Okay, winner takes all items for popular subcategory dominate, right? It's all shoes. What is the, however, I don't know. Oh, look, once you search for Nike, it's all shoes, right? While Nike can have shirt, can have what else? By the way, I said flooding, but Essence says whole set ranking. Wire structured presentation of organic items in subcategories. Then we have this. What is this? Oh, it is the Nikon ZF. Biased feedback loop. Feedback loop is biased via UVCC. What is UVCC? On umbrella vanishes certain costumes. Okay, UVCC. Let's do it here. UVCC. Wait, let me take a look at Ehsan's email. Whole set re-ranking. That is the song. Upper Valley Carrier Center. No, that's that. This is not a UVCC in e-commerce. Uniform Commercial Code. UCC, it's UVCC. No, okay. Okay, fuck that. So where did we find UVCC? Okay, via biased feedback loop via UVCC, the system defaults to show only one product. So even the thing with, we can even assume at the beginning our list starts from a uniform point. Then based on feedback we get, the feedback gets biased and we start showing all lenses. Then we have Yamaha. Well, by which they fixed this problem already. If we look for Nikon ZF, because there are engineers eBay. Right. So if I do that, so there are some lenses. There is one camera. Oh, it's already. Isn't it fucking funny? This is again all lenses. But I remember it was me and Monzer. We searched it. Naturally goes on lenses. I did it. Monzer and I did it. It was a lot of cameras. I don't know what happens. Maybe they put it back to all cameras, and then again people bias the system. That sounds very strange though. Yamaha. What is Yamaha? Isn't it bike? Flea market of uncomparable items, diverse results. No effective semantic form. Oh, this is another thing. This is more similar to this, like shoes, Nike and Nikon. Shoes takeover or lenses takeover, but Yamaha, I don't know what is Yamaha. Isn't it a motorcycle company? Flea market of uncomparable items. Yes, this one also can be improved much better with having categories. It's chaos. By the way, the question also rises when we say Yamaha, should we show anything? So this actually shows that the detrimental point processing may not be the best thing. Actually, these two are the two extreme cases. One case we are only showing shoes, and the other one we are only showing showing a uniform super diverse, which brings no meaning, right? What is Nike? And then we have a lot of shoes. What is wrong with this photo? And we have some sweaters or jackets. Proposed solution. As the first step solution, we can apply the organized presentation to any query that has item from greater than one leaf categories and refine the basic solution in the subsequent steps. The gist of the new experience is to have an implicit semantic. Subsequently, we can work with front end and design teams for tagging item subsets with the respective title. Slotted OL items in homogeneous blocks of 8 items to fill 2 rows in a list view from a given item subset. Okay, I didn't get this. OL, what is OL? Homogeneous blocks, yes, means categorized of 8 items. So each category in each row we show 8 items to fill 2 rows in a list view. So okay, that's it. Is it actually the last photo? 2 rows, not really. And that's actually super important. Wow. Refinements to the basic solution. Not all multi-cat queries are broad. Relaxing UVCC should depend on the confidence of the prediction. Use a smarter diversification dimension. Okay, this I don't. Fuck, I don't have this. Let me get access. Okay, we don't need them yet. Now let's go over mathematical model, by the way. So, yeah, good. I like this part of mathematics, coming up with a story, trying to talk in mathematic language. Part that is about solving the problem is maybe a difficult. Sometimes I think it just gets annoying, based on my experience. Um, so okay. Also in my note we had it. Let's say let's say that let's go over the Min Chen. Their system was, you had Q, I, J, and V, notation and definition. By introducing the components of the Internet Diversification Framework, which is applied to the set of recommendation items selected by the nomination and ranking stages. We use I to index users. So we read this paper before. I, user, J, index recommendation item. J is for item. I wish U was for user, I was for the item. And let there be M items selected for the page. So we have M items, 1 to M. User doesn't change here, right? And scores, they have a score SI1 to SIM. And the output from the multi-stage recommender system to introduce users' dynamic intents into diversification. We denote the space of intents as an, okay, now we had an intent space, which is V is intent space. Right? With small v representing a specific intent within this space. With specific intent and probability of VI, PR given VI is having intent V for user I. Prior belief, that's the prior probably given in the problem. prior belief of user I's propensity to have intent V for the current page, which could be derived from the output. This is so small. Where is it? Output of a classification model trained on past user behavior. So it is given, kind of. QJI. JI, what it should be? Probability of user I wanting the product J. Represent the value function of item J for user of value function. Value, not probability. User so. Actually, again, it says it is the probability. Okay. Yeah, you can always scale it, right? Which is available. Of course, it is intent agnostic because there is no V in it. But once we know that user's intent is V, we should have another more defined. It's like Bayesian, kind of Bayesian update. Represent the value function of item J for user I, which is readily available in existing intent agnostic recommendation system. We adopt a probabilistic definition of QJI, where it denotes the probability that the user I enjoys item J. They are all given, right? This probabilistic definition is chosen so that 1 minus QJI is the probability that he doesn't enjoy. As we will see shortly, this formulation facilitates the development of a probabilistic framework for diversification and is also widely adopted to approach within search context. To diversify based on user intent, I also have to read the Hulu model, right? But I want to do it after trying to come up with some models already. I don't want to overwhelm myself with information. I want to overwhelm myself with freedom and creativity. Oof. Bro, that was so cool. As we will see shortly, this formulation facilitates the development. To diversify based on user intent, we also need an intent conditioned value function. Exactly. Is it also given? Q of J I V, which is once his intent is V, his user I is V, intent is V, what, how much he values, or the probability. Now we have the, but we don't have probability of V given IJ. Yeah. It says Q of J given IV is over probability of VI given I, alright. P given I, probability of V given I and J, Q of JI, right? So I'm gonna write Q of J given I, probability of, well, what is probability of V given IJ over probability of V given I? So probability of V given I this one, oh, you cannot see it anyways. Yeah, because I want to see this. So probability of V, well, let me share you this at least. So here, oh, I should come here too. So here, probability of Q of j given IV is like once user I's intent is V, what are the odds he likes product J is general probability he likes product J times his probabilities, his intent is V once he's clicked on J over probability of his intent being V. The second term. Yeah, actually this one we don't have it. What about this second term? Probability of V given Ij. Is it just something we observe? The probability that user I has the intent V given the consumption of item J. So he bought item J, but how do we know his intent was V? How do we have that probability? This value depends on whether item J aligns with the user intent V, denoted as V in Vj. By definition of intent, the user would not consume an item that is not aligned with their intent. Oh, dude, it's so wrong. You just sometimes go to a shopping store, you end up buying things that you didn't know you want to buy them before going there. Consequently, if item J does not align with intent V, probability of V given Ij is 0. On the other hand, if item J aligns with it, then the item level intent prediction equals the page level intent. Okay, so if V is in Vj, you are saying those two probabilities equal? Actually, I don't agree. Like for me, if I wanna, what is the intent? Okay, for example, the paper was about YouTube. Intent could be learning, entertainment, and another thing was gaming, for example, right? So assume my intent is learning, right? And how do you define VJ, right? That's the thing. And the product that I click on it is a video of Andrew Ng about machine learning. So my intent is learning, product is in a learning category. You are saying that the probability of me wanna learn something, I is me, right? V is learning and J is Andrew Ng's video. So you are saying in general, probability of me wanting to learn something every time I go on YouTube is equal to probability of me probability of me wanting to learn something, right? Once I click on Andrew Ng, it is obviously wrong. Probability of this nominator is far bigger. My excuse, my apologies. So obviously when I click on Andrew Ng, the probability of me wanting to learn something is bigger than probability of me wanting to learn something once I go on YouTube, because then I may be there for entertainment. This is so wrong. This is so wrong. It's just so this is so wrong. Then they have their algorithm. Okay, I think they are wrong on this, but still it's a good, it's still, okay, I think I have to speak slower because I'm having a lot of, what is it called? Typo? No. Anyways, I'm not talking right, so I better talk right. Let's go back. We talked about this paper. I just want to say, it seems user in this paper, I, stands for query in our problem. I user, J item. Okay, this is the shit I just wrote. Maybe it's in the other. Caution. I cannot find anything here. So let's go to the paper itself. I may added it at the end of the paper, but my record here shows me that I never read that paper on my tablet. Therefore, let's go check. Okay, this is the note. Yeah. I will be user, J will be item. Yes, yes. Last time I also had problem with that. Ranking versus diversification. What is the feature? What? Flooding. I is Q. Alright. Perfect. Da 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 da. Okay, I want to add, first of all, delete this note. So it's just Q is user. So let's go on our story. Okay, let's build our own story based on whatever we have so far. Do you want to go on the board? We can go there, but I don't know. Perfect. Is it what I'm showing you? That's what I want. So what do we have? We have a search query. Somebody searches something. So we have a user. He search a query. Searches query Q. Right? This Q can be, for example, Nikon ZF, right? And then we want to come up let's take it simple. right? Our first story is that, so we have a user, they search query Q, and what's going on? Let's assume we have M products 1 to M, and which are related to the Q, right? But how do we know if a query is related to a product? That's also something, right? How do we know if a query and a item J are related? Okay, let's simplify, right? I say let's simplify. Let's assume for query Q, our search engine or whatever platform says, our platform says product J in 1 to M, it gives us M product that are related. Simplify, just let's focus on ranking, right? So they are M related product. How do we rank them? In order to capture the essence of customers' purchase or clicks affecting our score relation, right? Let's assume for query Q, SJQ is how related is product J to query Q. Based on our past history, based on the history of user behavior, right? So what is this history? Our history is, we have our history, baggage. Our platform has gone through some traumas and good memories. So we have, for example, N, for example, 10 to the 10 clicks before for product Q, for query Q. So what was the story? Today is August 6th. Up to August 5th, there were a lot of history of people searching Nikon ZF, and we showed they clicked on different things, right? So on August 6th, when we are searching Nikon ZF, our platform, so this, we had n number of clicks, and n1 number of time they chose product 1, which is a lens, and 2, they chose product 2, which may be a lens but a different, I don't know, what is it, focus? What is it called? Magnifies the lens. And number, I don't know, J, for example, it can be a camera, which is Nikon ZF. And number, I don't know, NM is number of time a particular case was chosen. By the way, we can assume, as I suggested, that we have these subcategories, right? So M1 to M is actually kind of M1 union M2 union, and we have K categories. Number of maybe large K is better. Well, sometimes you can get very granular and say, okay, we have M product, then we have capital M number of categories. That is not very helpful. We want to come up with a classification of this product, which is K can come from a classification done by what is it, done by the platform. All right, take it as given. So we have these K categories. Yes, somebody may say we can optimize also on K, how many categories we are, but we need to stop somewhere in order to start saying, oof, dude! What a punchline. We need to stop somewhere in order to start thinking. Bruh! Let me write it down. We need to start thinking. We cannot think back, and we need to have some principles. Perfect. So we have K categories. By the way, we have to present this model to Ehsan, to Monzer, and see what's up. Maybe they say this is amazing, and actually we have K-1 categories, or you should start from 0. Or they say, oh, it's good actually, but this is another model. So let's digest. Let's see how I see the problem. And how I create my model. I'm now in a God mode that I'm creating a model. So I'm allowed to have assumption. I'm allowed to make decision without any explanation here. So all right. Getting back to the story, this part was N1, N2, Nj, Nm. Each product of our M product was clicked, and you can say that a score, the score is probably is like, this is the story I have in my mind, my intuition of how platform works. So for example, you can say S1Q is N1 over N, and then S2Q, SMQ is Nm over N, right? The thing is that we are ignoring that these products are in the same category. For example, we know that in case of Nikon ZF, lenses have a lot of amount of clicks. Therefore, you may say, and if it is ordered, N1 is greater than N2, and then S1 is greater than S, right? In a decreasing order. If you want to rank the products in based on click-through rate, right? The problem is that S1, which is for product 1, is a lens with focus 2 and 1.4, and S2, product 2, is another lens with focus 1.8. Maybe the first 10 products, they are all lenses which are in the category M1, and they just have different focus points, right? Let's say given so that I don't think back. So do we want to show all lenses? That's stupid. We rather show 2 items from category 1 lenses, then go show some items from category 2 which have much less click-through rate in comparison to the third item, but they are from a different category. Therefore, we have a diverse list. Or you can say, Amir, let's just show the categories, and in each category, let's show the product. This will be another solution which is really promising. Anyways, this is it. So we have this score based on a history, right? Now I want to tell you what's up. What we have. We have the scores based on the history, and we have different categories from another team that gave us the categories. What else is going on? Also, we had IQ, V, I, and J. I to J, we still have it. I is Q, and V. V is the intent, right? Intent. Well, we can see intent can be any of these products, or you can also add another option that none of them. Fuck, just never think about it. We make sure in eBay, we make sure you buy something. That's our motto. So no option. But okay, intent, user have intent v, which I can say, I kind of like the idea of saying v is actually the categories we want. So is it how true is that? It is nice if the intent space and the category space matches. Like a customer is looking for lens. Another customer is looking for we can say they don't match, but we can also assume they match because at the end of the day, once we categorize the products, we have these K categories, right, which is based on users' behavior. At the end of the day, once customer clicks on a link, because we don't have access to their inner intent, inside intent. What we have is their action, which is choosing one of these products, and they fall into one of our categories, right? So can we say V equals K? I don't care about your inner category, inner intent. You choose one. I have K categories, right? This is the story. I have K categories. You pick one of the products and it is in one of my K categories. So I say your intent will be K. Now the question is, what is our objective? How do I want to sort this? And, in order to diversify, right? Okay, my problem right now is that if we have this categorical presentation, that first I show them different categories and then the list, there is no difference, and especially if K is a small number, nothing can go wrong. Well, what is wrong with showing these categories? I mean, how can I compare it to something else? What is this objective function? right? I have a categorical presentation. It works. What is the question? I don't know what is the question. Let's see what was the purpose of diversification in. Okay. There we assume that they have different intents. So the algorithm's sense was that we are diversifying on intent. So what is the difference if it is the case? What is the difference? I think with this paper, we should just come up with an algorithm to diversify, and then it's just running live experiment result and understanding what's up. Right, they just came up with an algorithm to rank, and then they did it, and then they ran experiment. That's it. I don't know what is, like, what they are doing. How are they comparing these results? This is their algorithm. There is no extra math here, right? You can see that. Yeah, I don't get it, to be honest. I think it's the time. Like, I generated a lot of mathematical framework parameters which describe the elements of the story, but I don't see where the optimization lies. How can we compare one ranking to another one? Or, like, it sounds very straightforward to me now. I don't see any challenge. Okay, one challenge I see, which I don't think is the problem here, is that, like, a game theory framework that we say that we say right, we have a system, we have a ranking algorithm, for example, working based on CTR, but we want some diversification, right? So it just shows that we should not set CTR as the metric to rank. We need to consider a combination of CTR and diversification into ranking. and then see if that system will get saturated again or not. Or we can say, if I diversify, how much revenue I lose. Right? Revenue is a good metric, right? Actually, revenue is a great point. Let's say we don't have only one consumer. We have a bunch of consumers. That's actually what we were talking about yesterday too, right? So far it was just one consumer and this, all right? Let's assume by our history we have N1 and let's assume we have people. This is people on Earth. This is America probably, and this is England, this is Europe, Mediterranean, Africa. Here is the Olympics, 5 rings, and then we go some stuff here. I think Scandinavia is like this, Caspian Sea, Iran, love you, and then the rest of Asia which are behind. Here is Japan. All right, here is home. Anyways, so we have these people, and for query Q, we want to say like North America, including Mexico, is buying lens. South America, they are buying the camera. And rest of the world are buying cases, right? This is based on our history, this is based on the scores we have, S1, S2. Okay, shit, yeah. So we want to have a score for different categories, which we can say category K, right? A score. We can say score for category K. Is that true? Sounds true. How should I show score for category K? I will. S is score for item. Score for category is U. U for K in K, UK is the sum of SJ Q, where J in MK, in the category of K, right? This is the score for the category. Right? At time 0. Okay, this is actually true. Okay. Okay, I assume that, yeah, products are sorted based on their score at the beginning. Let's assume that there is no harm in it. And then, but we didn't assume that M1, M2, MK are ordered, right? This is a wrong assumption to have, actually. maybe, for example, right, maybe one lens with focus power 1.6 is super popular and it's on the top. Then we have an camera which is also popular in the rank 5, like first for our lenses, then we have a camera, then at the end we have like some lenses with shitty focus or very good, like rare usage focus. So assuming that products are sorted based on their score is completely fine, but assuming that the platform is showing the products based on their categories is not true. Actually, this is not true. Okay, so M1, M2, MK are just categories, which is completely fine. We don't need to change anything. And I'm just saying if J1 in M1 and J2 in I don't know, MS1, MP1 and MP2 and P1 less than P2, it doesn't mean that J1 is less than J2. That's what I mean. All right, perfect. And so these categories are not in order, they are mixed. What we are saying is so we have a score for each category as well. I think the missing part is our DCG. Oh, we were talking about consumers. Sorry, I totally forgot. Oh, shit. Yeah. Okay. We are talking about consumers. Where is my earth? Oh, okay, it's here. So, um, so sounds good. I had some inner thoughts. A user comes, search query Q with probability S1, he wants product. With probability SK, he wants product from category K. Right? And what is a user satisfaction metric? Users satisfaction metric. For this, I wanna have a flashback to the time we read the paper from Negin. Actually, they were sorted based on their types there. Right. Let's assume drops, right? Let's assume if a user is in user's intent is category K, and what was my assumption at the very beginning? So first story is that we are showing a list. Showing a diverse list. Case 2 is show by category, right? I don't know what happens here, to be honest. Which one is better? You have to compare case 2 with case 1 for sure. Okay, 1, so let's assume that every item that the user scrolls on and doesn't click on is a negative value, right? Until they find their products. So user is from category K or type K, and let's assume let's assume so what will be, let's compute the loss of user K. Loss of user with type K, right? So let's say J0 is K is the minimum of the J, which J is in category K, right? First, what is J0K? J0K is the first product that any user finds from category K, right? Then user's loss equals something, f of, or loss function, L of J0K, right? Which L is an increasing function. The deeper they have to go to find that shit, they are observing more loss. The search for them will be more annoying. So then the total loss will be sigma for each user we have. Well, we can say the propensity as well. S J1 to M. It also still is not very quite good, but still it's far better. Okay, we got to some point. J1 to M. Sj times L. Okay. S is so user's intent, by the way, remember, user's intent is for the product, for the category. User's intent actually user's intent equals categories, right? So and then we have products that they have their own utility. So I say K from 1 to K and UK so a new user came with probability UK, he is from category K and J0K. What about this? We want to minimize this loss. That's a good beginning story. You may say, okay, his loss is once he finds first 4 items from his category. Something like that. Okay, that's a good story. I think I want to write it down. Then I want to go over the story, add more leaves and branches to the story, getting more details. Now I think I got to a point that I can say something. Therefore, I deserve Counter-Strike for 2.5 round. Yeah, that's a good break point. Then I can go in more depth in my fucked up brain to narrate the story. Ooh, you're too loud. That was a good session. I loved it. But I want to write it down in Overleaf now. I don't want to go ahead. Let's take this story for now. Then we can check this and also 3 check Negin's paper. Because they had a similar system there. And then we can, next step, how will it change the ranking? Is it an equilibrium or not? Alright, perfect. Too many questions, too many things to write down. Oh, bro. Did he headshot me? Come here, bitch. Okay. 4 of them. Bruh. Yeah. Yeah, I am curious if that ends up in an equilibrium or not, but did you see the momentum? Herding effect? Of course he has a gun. He has a sniper. Okay. Ah, dude, I had him. Where are they? There it is. They're this side, motherfucker. Ooh. Ah, who killed me? edge. Alright. I think I could do much better. I can do much better. Bro. Oh shit. Did you enjoy the headshot? Oh motherfucker. Where am I at? I was on something. I just... Oh, this situation ain't good here. Somebody else killed me, right? This shit sucks. Last round. That was good actually, yeah. I see that was fair. Then we can get into other... Yeah, actually now I have time to check Negin's paper. I don't know how to compare it with the second case. I don't know. two of us. These motherfuckers are good. Bro, don't kill me. Uh-oh. Dude, I got her. Dude, why did you kill the other one? Just because he's sitting? Fuck you. Oh, bitch. Okay. This guy is just knifed. Because I killed him. What kills me with the gun I have? That's so unfair. What is shooting? Oh shit. No fucking way. This motherfucker! Just grabs his knife all the time, bro. Headshot. Bro. Okay. This year, Kanye is so good. I got knife twice this round, right? Damn, that felt it. He was so fucking good. I guess I will go on my own. Now this is like, for now my brain opened again. But this is the unhealthy version that I'm playing just for the fun, you know? This is the addiction part. My brain is ready to get back to the game of research. Oh no! Can I fuck me? You know, it's like Matrix. If you move it a bit, you can give it a spin, right? Dude, you should move. I should move. I have such a beginner. Unbelievable. Unacceptable. felt it hurt my face. Bro, where are you? No, man! Bruh. Dude, I want to go play paintball so much. Tired of it. Oof! It's shot after a jump. Oof. Oof. What are they, dumb? What's happening? They used to kill me in a second now. What's wrong with them? Bro, what are you talking about? Four of us here, what are we doing? Oh. Oof. Oof, dude, that was a nice job. Teamwork. Oof, that was nice. Oof, I feel so nice. Three direction. Your face. It's your face. Oh shit, who hit me from behind? Is there a rule that we should not use the flanks? Maybe that's the... Like I have all the time in the world. Bro, fuck me. Oh, snap. Die. Fuck. Let's kill some people. Oh shit, dude. How many of you? Three of them. None of them are here. Bro, fuck. Hold up. Bro, I had to kill him. I just wait for him to kill me first. Damn, I couldn't kill him once. Bro, what's happening? Actually, I was really good. Okay, now I have to exit. So let's go look at the... Oh no, shit. Where are you? Okay, you're here. Now let's go take a look at Nagin's paper. Yeah, that's it. That's the graph. Still, I have a feeling for fairness on this graph. What is a fair ranking? A fair ranking. Merit that sorts based on merit will have... How do you find the merit, right? That's the question. Okay. Yeah, you wanna, if you have a merit, I love my hair. So if you have a because we know that because of consumers' limited attention or laziness, the fact that they don't go all the way down the list, being at a high position brings you value. Even just putting at you, right? You can see this synthetic data, the black curve. Still, the ones who are at the top position are selling more. Now you can say, I want to reward the products that are better. I want to make my curve as decreasing as possible. I want to sell as soon as possible. Well, first of all, this is just fucking merit based. This is not for the benefit of platform. For the benefit of platform, you want a more flat version of the curve. And Ehson was saying that Ehson's paper says that DCG is actually these probabilities that we have here. Let me see. But these probabilities that we observe here, but if it is the case, if it is these probabilities that we observe, how can we say? If we come up with another permutation, those weights, those probabilities will change. And you are saying we should compare each list with the probability that it gives to us. So they assigned a, well, I don't remember the name of the distribution. Yeah, it is about welfare. So the thing we do is, first, as I wrote here, we want to write this down. Write this down. Then we will go check Negin's paper. Perfect, sounds good. Fuck, I played too much. There is a sweet spot, I think it is 1.5. Sweet spot is 1.5 round. Like your first round is warm up, you show up in the middle of the game. Then the next one is the sweet spot. Or 2.5. 3.5 is terrible.